Today we'll be looking at measures of association. Just a minute. Yeah. We are making noise. Yes, today we'll be looking at measures of association. So we'll be looking at understanding the concept, risk, and odds. Under the measures of association, we are going to be looking at two main things, two measures of association: relative risk and odds ratio. Hazard ratio is in the same category, but it is better not mentioned in this lecture. We would only make mention of hazard ratio and explain hazard ratio in survivor analysis. So try to explain hazard ratio here may not go well. But the two commonest measure that we're discussing are relative risk and odds ratio. Before we talk about the relative risk and odds ratio, we ought to understand the meaning of risk and odds. Then before we understand relative risk and odds ratio, then if it is for workshop, we also run during the workshop, because we have done it in the workshop also, when we're treating proportion, comparison of proportion, when we discuss chi-square. We also attended to measures of association, because they address categorical variable also. And we actually run it with SPSS and look at the result. But the only thing we will not do is to run, but we still interpret result also in the lecture. Now, let's quickly understand the meaning of risk, because you hear the word relative risk, odds ratio. You also know that even the relative risk also can call it relative odds. Even odds ratio can be called relative risk. Odds ratio can be called relative odds, and relative risk can be called risk ratios. So risk is the probability that a particular event or outcome will happen over time. Risk is the same thing as probability. It's only that risk, the word anyway, is wider. The meaning, the English usage will be wider than that of probability, because it means different things to different people. But for statistics, risk and probability is the same. But if you want to now begin to delve into different type of risk, you can have speculative risk. People think risk is always about something bad. No, in English usage, it may mean something bad. The probability that something bad may occur. You see, you are traveling at night, you are taking risk. They are trying to say that you may have unforeseen occurrence. You may know accident or many other theft or whatever, bandit. So you're traveling at night, you are taking risk. You only think about bad things. But in statistics, risk just means probability. Even if it is good thing, probability that good thing will happen is also a risk. Why the people that get involved in investment, portfolio investment, they talk about speculative risk. They know that if they invest, they either lose or gain. They either lose the money or they gain from it. So they both bad and good, they have learned to accept both. And that's why they call it speculative risk. The risk can be you gain or you're just speculating. So that is that. But for statistics, risk and probability means the same thing. Now, if risk and probability means the same thing, what is odds? And what is the, so we know probability because we don't want to delve in, because we have discussed probability, chance of occurrence of an event. Everybody knows that. And it's between 0 and 1, or it's between 0 and 100. 1 and 100 mean the same thing. 1, when you are expressing fraction, decimal, talk about 1, 0.2, 0. This. But if you want to express as percentage, over 100. 0.2 means 20%. So changing fraction to percentage is a matter of multiplying by 100 or dividing by 100. So when we talk about probability, we use them. You can use any of them. You can say the probability of the event is 0.2 or 20% or 50% or 0.5. So we know that. So when you express your study, maybe you tabulate your study, you put your percentage, that is relative frequency. That relative frequency, when you put your result in percentage, you express as percentage, is relative frequency. It's a probability. You don't know that it's the probability distribution. You are telling us, oh, if that is 35%, you did also ethnicity, the others or Ibibio is 20%. We are saying that the probability of finding Ibibio among these people, if you gather 100 people, you get 20 Ibibio. The probability of getting Ibibio is 20%. That's what I say. So it's probability when even your table is probability table. We call it relative frequency approach to probability. That one is under probability. We have discussed it, and I keep on saying, go and watch it. It's there. Go and watch the video of probability. We explain. So we have established the fact that risk and probability is the same. What of odds? So you can easily understand the odds of an event is the probability that the event occur over the probability that it did not occur. So if that is, you know, the probability that event did not occur is 1 minus or 100 minus the probability that it occurred. So if I say the probability of it raining today or tomorrow, the probability of it raining tomorrow is 0.6, 60%. The odds will be probability, which is 0.6 divided by 1 minus 0.6, because what the 1 minus 0.6 that is the probability that it will not rain. The probability that will rain is 0.6. The probability that will not rain is 1 minus 0.6, which is 0.4. The odds that it will rain tomorrow will be 0.6 over 0.4, which will give you 1.5. So you see, odds is probability over 1 minus probability. That is why you see odd is risk, which is probability over 1 minus risk. Then if you change subject of formula, you will see that risk also is odd over 1 plus odds. Can you see? Odd is risk over 1 minus risk. The risk is odd over 1 plus odds. This you will see if you look at the table on the right side. You see the table. You see the table just depict the relationship between both of them. You get to know why those people that usually bet for football game, they use odds. You're going to see the reason they use odds more than risk. So look at it. We know that probability is from 0, cannot be less than 0, cannot be greater than 1. So the ranges from 0 to 1. See this table. But the odds, if you use the formula we just talked about now, odds is equal to risk over 1 minus risk. You know that if probability is 0, odds will be 0. Can you see? If probability is 0.2, odds will be 0.25. If probability is 0.5, odds will be 1. You know, because the probability is 0.5. The probability that it will not happen will be 0.1 minus 0.5, which is 0.5 also. So odds will be 0.5 over 0.5 is 1. So when probability is halfway from 0 to 1, because the smallest is 1, the highest is 1. The smallest is 0, highest is 1, possible 1. So the midway will be 0.5. When the probability is 0.5, odd is 1. So odd has traveled faster. So if you now if probability increase, you come 1. You can try. The odd will be infinity. Because if you say odd is probability over 1 minus probability, if the probability is 1, it's going to be 1 over 1 minus 1. 1 minus 1 will be 0. 1 over 0 is infinity. So the odds has value, a wider range of value from 0 to infinity. Can be as high. Look at this one. One probability is 0.999, odd is 999. So odd can be greater than 1 to infinity, sir. To infinity. So the one is probability travel from 0 halfway to 0.5, or travel from 0 to 1. It has doubled the journey of probability. When the probability now travel the last one, all has gone into infinity. That's it. So odds usually have bigger value, and that is why people that speculate or maybe they bet for all those football, they use odds, because if they are comparing the chances of two teams winning, if they calculate probability, it will be close, so it will be difficult for them to judge. But when you convert it to odds, you can see the wide margin. It is easy to know which one will likely win through odds rather than probability, and that is why they use it. Now, the explanation still further odds, probability of the event over 1 minus probability of, that is P over 1 minus P. Let me reduce that thing. Now, this one is just a picture, the pictorial view. If you say odds, look at this picture now. If this is odds, if this is probability, you can say probability is that small area, that sector, over the total plus that sector involved also. Can you see? So if you say that what is the proportion of women in this class? If there are 10 and women constitute 6, you say 6 over 10. 6 over, even the 10 also, the women are still there, the women and the men. So it's the same thing, that's the way you calculate probability. But odds, can you see? The probability over 1 minus. So if it is odd now, you now say, what is the odd that women of having women here? If the probability is 6 over 10, the odd will be 6 over 4. Can you see? You remove the 6, the remaining is what you have as denominator. And that is why you can, when they remove the sector, the other sector is the denominator. So the sector over the other sector, that is odd. But the probability is the sector over the sector plus the rest over total. And you're going to see later, the second part of the diagram is talking about if that probability or is very small, or the odd is very close to very minute, the value of odd will approximate probability. Probability and odd will be. That is what you see now. Look at the table. When probability is 0, what is 0? When probability is just a little bit greater than 0, so the odd also, though it's greater than probability, but it's a little bit greater than 0 also. So the value of odd and probability are close when we are talking of smaller value. But as the value probability increases, odd begin to go haywire. To the extent that when probability travel halfway, odd has doubled the journey. And when probability travel the last halfway, odd has gone into space, has gone into infinity. I think you can conceptualize the logic behind that. Now, let's now come to issue of relative risk and odds ratio. Relative risk, also known as risk ratio. A ratio is anything you get by dividing two quantities of the same unit. When you are dividing two similar things, when you divide them, their unit cancel, become ratio. What you have has no unit. I give an illustration. I usually give the illustration. If you see somebody travel 400 kilometers in 4 hours, you see, the speed will be comparing kilometer over time. Both of them are not the same quantity. So whatever you now get now, 400 kilometers over 4 hours, it will give you 100 kilometers per hour. So the person has traveled at the speed of 100 kilometers per hour. Can you see the speed has unit? But if you say that somebody travel 400 kilometers, another person travel 4 kilometers, you're comparing it to divide it 4 kilometers over 400 kilometers over 4 kilometers. That is 100. It has no unit. You cannot say 100 kilometers. It has cancelled. The unit has cancelled because both of them are measured in kilometers. So it's you. So we are just telling you that that person has traveled 100 times more than the other one. That's just it. Now, so both of them are ratios. That's just the truth. Both relative risk and odds ratio are ratio. So you can as well call relative risk ratio because you are dividing two risks. You can also call odds ratio relative odds because the relativity there is that you are dividing one by the other. You are looking at how many times one is greater than the other. So it's also risk ratio, relative odd. So risk ratio at the same time relative risk, odd ratio at the same time relative odd. So odd ratio is used when occurrence of an event, or for example a disease, cannot be calculated because the event has not occurred, or the event has occurred rather in the past. So even the event even has not occurred, so you can still calculate odd. But exclusive, you discover that you cannot calculate risk if the event has occurred. The probability we talk about is risk, it's a futuristic thing. Something will not happen. It has rained. You're not saying that what's the probability that it rained yesterday. That's rain. So if the event has occurred, the probability is for futuristic event. Even when we look at the classical approach like tossing die or tossing coin, you are looking at, you see that if you toss a die now, you toss a coin, the probability that it's head is 0.5. People will think if you toss the coin 100 times, 10 times now, 5 should be head, 5 should be tail. Well, you won't. You can even toss 10 times, all of them will be head or tail, or 9 of them head, and 1 is tail. You know? But before you can get down your 50-50, you have to toss it many times, thousands of times, or millions of times. So you can just get the approximation of the 50-50%. But the issue there is that is probability. For the probability is futuristic. You can calculate probability, yes. It may not, when it comes out, it may not be the same. In fact, the highly probable event may not occur. Even the event that is rare, that is least probable may now occur. So, but odds is now used in a situation if the event has occurred. So instead of it doesn't make sense to now, it's just a way of, circumventing so that something can make some sense. That's the way I see it. So if the event has occurred, so there's no point calculating the risk that you can. From the risk, you cannot calculate the odds. The odds. So though the way it works, usually work with maybe you are using another risk to calculate another odds. You are going to see, but somehow the odds depends on the risk. From what we have just said before, 1 minus odd is 1 minus risk. Odd is risk over 1 minus risk. If you have your question, you can be sending in, you can be shouting it. So odd is 1 risk over 1 minus risk. So you can easily calculate odds from the risk. So odds ratio, compare what you just happened, what you do in odds ratio and relative risk is you have 2 groups of people, or let's say, or subject. Some group are exposed to a factor that can cause an outcome. I like saying like that because not everybody here are medical people. Some people that are, so I like my language to be universal, but sometimes also, though most of the example we use medical base, I try to, when we say disease, it may not necessarily be disease, maybe an event. Why the causes of disease, maybe you call it factor. So factor, event, or outcome, factor and outcome. So if you have 2 groups, that are exposed to a factor that causes an event or an outcome, and another group that are not exposed to a factor that causes the event. The relative reward is just to calculate the risk of the event among the people that are exposed to that factor and the risk of the event among people that are not exposed, and try to see, since you want to test if this factor is responsible for the event. So it makes more sense if you want to divide the two, to put the risk you calculate for the people that are exposed at the numerator and the one that are not exposed at the denominator, because most of the time you expect the risk to be higher among the people that are exposed to the factor and to be lower. So in such a way, if you now put the one that are exposed to the factor, you expect to be higher. When you divide, if it's actually higher, it will be greater than 1. You know, when you divide something, the numerator is higher than the denominator. It will be greater than 1. But it may not be like that. But that is the reason the convention is, when you are dividing, since it's a ratio, is about division. You put the risk among those that are exposed to the factor at the top, and the risk that among people that are not exposed at the bottom, to see if the one at the top is bigger. It will tell you how many times it's bigger. If it's 2 times, if you divide it's 2, that should be 2 times bigger. It's the same thing with the odd ratio also, but it's only that you cannot measure the disease, the risk of the disease now directly, or the risk of the event directly. So you now measure the odd. So you expect the odd to be greater of the exposure, the odd of the exposure to the factor. What we are looking at is the odd that, because the disease now, in comparing odd, the odd ratio, what you are actually looking for, that factor. What is the odd that this person was exposed to the factor than the odd that this person, because when the thing has happened, what you have with you is not the exposure, now is the outcome you have. People that have the outcome, people that don't have the outcome. So you are now looking at, of course, people that have the outcome, the exposure will have been passed in the past. So the exposure, the odds of the exposure divided by the of the exposure among the people that have the outcome over the odds of the exposure among the people that didn't have the outcome. So that is what we talk about. So you now see that the odd ratio is used when something has occurred, the event of interest has occurred. It will bring you to the health balance now. Example of study where you use odd ratio: case control study. The situation where you have the case of people that have the disease and people that don't have the disease. So those are the outcome. The exposure has happened in the past. So the exposure would have, people that have the disease, they should have been exposed in the past. So you are not calculating the probability of the exposed now, you are calculating the odd of them, because the probability, the exposure has happened, so you cannot calculate the risk of exposure. You now calculate the odd exposure among them and now divide it. So in the example of that, apart from case control, is cross-sectional study, because when you are doing cross-sectional study, what you are measuring is there. What you think is causing and what something is causing and what is causing something, all of them are there. Just like you say obesity and hypertension. Obesity is a risk factor. Hypertension. You do cross-sectional study where you measure people's height, weight to calculate the BMI. You also measure their blood pressure, if the blood pressure is high, if they are hypertensive. So in that case, you cannot even say that because anybody that is hypertensive now, it's going to be difficult to say that that's one of the drawbacks of cross-sectional study, no temporal sequence, because you cannot establish, not that there is no, but you cannot establish it. So you will not say, oh, some people, most of the people that are obese, they are hypertensive. But some of them, they were hypertensive before they became obese. Not all of them that became obese now led to hypertension. Some of them were hypertensive, later they now became obese. Even when they were hypertensive, they were not obese. So you cannot really say which one comes first. So in that situation, it's difficult for you to say that you are calculating risk. You are calculating risk. So in that case, you calculate odds. So you do odd ratio. In case we have already established the case control, so the event has occurred. So you only calculate odds. Now, most statistical method, such as logistic regression, that are employed to identify the predictors of outcome and remove effect of confounder, they use odd ratio to measure the strength of association. So you're going to see from here that don't mind people. They think you got to see that odd ratio is more universal than relative risk. You can use odd ratio for anything. Even for core study, you can calculate odd ratio. You can calculate odd ratio. For experimental study, you can calculate odd ratio, especially when you are trying to look at factors. It's the odd ratio that is the statistic you use. But you're going to see for relative risk, I think did I talk? Yeah, I think this slide will throw more light because I have talked much about the odd ratio now. Let's talk about the relative risk also. Yeah, both of them, they are being depicted here. Risk can be calculated only from data capture when the event has not occurred. So now, look at this picture now. This line you see in the middle is the present. It's today, now. So something happened in the past to the left side. So something will happen in the future. If you can see now, you can see.
Where's the mop? The mop.
Somebody who is mopping, don't mop what we are doing. Please, Dr. Adeshina, I've muted you. Sorry for that. I have to look for that person. Now, the line you see in the middle is the present. Towards the left side is the past. Towards the right side is the future. Now, you will see that from the future, something happened in the past, rather, on the past side. What have happened in the past? You can conduct both case control and core study. But the core study is a special type. So what we are talking about, what happened in the past now, we are talking of the outcome of interest. Maybe the disease now, the event of interest, the disease. If the disease have occurred in the past, you already say you calculate odds. So the case control, you calculate odds. You can do core study also, but they call it retrospective. You are looking back because what has happened in the past was that the risk before the outcome occurred in the past. Somehow there was a record of the risk somewhere. And still in the past also, when the thing happened in the past, there was record or a record of when it happened. So at the end of the day, both the exposure and the outcome were in the past. But because there were record of the exposure in the past, you can calculate risk from, at least you are trying to calculate risk now. Though the risk you are calculating now is risk them, but because there were data then. It usually occur in occupational study because in many industries, there are record of many things in industry, in a place of work. So you can dabble into the record and look at people that were exposed, for example, people that were exposed to dust. They didn't have any lung disease, they didn't have problem. 30 years ago, they were employed and they were exposed to dust. And some were not exposed to dust. Maybe they are working in the same company, they are not exposed. They were in the office, some were on the field. So after maybe 5 years ago now, after 25 years or 10 years ago, after 20 years now, you now see you will now go and get their record also. Now see people that have developed the outcome, the lung cancer or lung problem among both people that are exposed and people that were not exposed, because there are some people also, they were not exposed, they may still have lung problem. When you say can cigarette cause something, It's not everybody that smoke cigarette, that will cigarette will cause that particular thing. And there are some people that will not smoke, they will still have the problem. But there are some other things that can cause it also. So in that case, you see, cohort study also you can get past data. You call that one retrospective cohort because you are looking back. By nature, case control is retrospective in the sense that we know that the disease has occurred. So even what you are asking, the risk you want to have also, you know that matter for occur. So both of them, both retrospective cohort and case control, they are retrospective. So let's move forward. When we move forward now, look at the future. Now, this is now. You can only say, oh, these people have this risk, these people are smoking, these people are not smoking, or these people are using OCP, these people are not using OCP. Now, you are concerned about the risk, how will it lead to disease in future or the outcome. The outcome has not occurred, but you're just starting with exposure. So in that case, you can calculate probability risk because it has not occurred, it has not happened. The event has not happened. You can calculate probability. Now, you can say, oh, these people that are exposed, they are more likely to have the disease, to have the outcome. If you look at it, what are the different type of studies that are in this class? You can see, they call it prospective, that you are looking to the future. Cohort study is there, clinical trial, that the experimental design is there. Experimental design is prospective also, is looking to the future. It's only that their own future is near future, while the cohort study is far future. And at the end of the day, that's why cohort study is the most expensive, because you look into the far future and be waiting for 20 years or 30 years, more than that. And if the outcome of interest, the disease is very rare, you may not even see appreciable number that are developed it. It's very expensive. You have to do follow-up. No, you spend a lot of money. When you ask people to come, you want to be taking some measurement from them. You have to be giving them money, for them to continue. You come in, you recruit them. You have to demonstrate. Nobody does anything for nothing. So that's why cohort study is the most expensive study. We can see now in experimental design, in a prospective cohort, well, not a matter of in cohort study generally, not even the other one, retrospective also, you calculate the risk. So now, cohort study, experimental design, you calculate risk. If you can calculate, so you can use relative, you can compare risk between the two, exposed and non-exposed. So how do you compare two relatively? Dividing this risk by the other one, that's relatively. And that's why you calculate relative risk in that sense. While in the case control and in case of cross-sectional study, you cannot calculate it, so you calculate odds. So the issue there is that in cross-sectional study and case control study, you cannot calculate risk. You can only calculate odds. But in experimental design and cohort study, you can calculate risk. You can also calculate odds. So can you see? You can also calculate odds. It's only that you cannot calculate risk for some case control and cross-sectional study. But for any other study, you can calculate odds. So, and that is why in a situation where you want to, even in all these other study, cohort study, experimental study, where you're analyzing, you want to do logistic regression, the statistic used there is odds ratio. So you can calculate odds. Let me just give I usually give social example for you to conceptualize. The relative risk, yes, is the real risk we are measuring, because it's the real risk. It's not the odds you are measuring per se, but the risk, the risk you want to compare, the relative risk is actually the one that compare the risk more than the odds. So you can say, okay, maybe the HOD is the relative risk now. And you are junior, maybe a consultant lecturer, junior lecturer, you are the odds. You discover that you are more universal, you can do many things. You can go to the clinic and do work and see. You can even go and, if a HOD is not available to go and do something, you can go and attend a meeting on his behalf to represent him. Or when he's supposed to be in clinic, he's unavoidably absent. So you can go and represent your HOD. So you can do what you are supposed to do. You can also do it. So, but imagine you are supposed to be in one meeting. Now ask your HOD, sir, can you, I will not be around. Can you go and attend the meeting for me? Is it possible? Now telling your superior that he should go and represent you. Can your superior represent you? So that's just it. You see that where your superior can do what your superior can, where your superior can go, you can go also. If he allow you to go, he designates you to go. But watch where you are going, your superior has passed that. You cannot designate your superior. So relative risk is not possible. So in some situations, the odds is possible in all situations. That's just the summary. So odds ratio is possible in all situations. However, relatively is a more accurate measure of the risk of the disease. We'll talk more about that later. Now, let's quickly look at comparing risk or using 2x2 contingency table. Occurrence of event as a result of exposure to certain factors. The occurrence of event rather are there as result of exposure to certain factors. So the relationship between exposure to a factor and occurrence of an event can be depicted in a 2x2 contingency table, where you have the row represent exposure to the factor, while the column represent occurrence of the event. So the row, by convention, the row is the exposure. Look at it. Look at this example. Exposure status, exposed, not exposed. The occurrence of event is the along the column, vertical. Yes, no. So and by designation, these four, it now give you 4 cells, 2x2. So the exposure is either there or not. So there are 2 categories. The outcome also either there or not. There are 2 categories. So when you cross tabulate, it gives you 4 options. So the 4 options is the person is exposed, he has the event. The person is exposed, did not have the event, or the person was not exposed but had the event, or was not exposed, did not have the event. So it's designated as A, B, C, D, like that. Now, because it's a lecture, during the workshop, we usually have time to come down to to break it down. So we may not have that type of time now. But even you will see something. To calculate risk is very simple. Though I usually use an example rather than refer using formula to explain. I think this first one is yes, the risk. To calculate risk and relative risk. An example will give you more understanding. Look at the example we have here. Smoking, yes, no, that's exposure. Lung cancer, yes, no, that's the alcohol. So we have 1,500 people. Out of which 500 are smoking or smoke. 1,500 not smoking. So after the end, 30 totality developed lung cancer. 1,474 and 470 did not develop lung cancer. Everything, either you had 30 to this, you give you this, or add this to this, give you this. So the meat, so the total is what is along the edge, but the real things are the value in the middle, the cells. 25 smoke and develop lung cancer. 475 smoke, they didn't develop lung cancer. So we make up 500 people that smoke. Out of the 500 people that smoke, 25 develop lung cancer. 475 did not develop. Out of the 1,000 that did not smoke, 5 developed lung cancer. 995 did not develop. Even people that didn't go to school, so when they look at this figure, they will know that this thing is common among the people that smoke, because look at it, fewer people smoke than people that didn't smoke. There are more people among the fewer develop lung cancer than this. So we will know that it's even commoner there. But to quantify it, we say that it's risk ratio, or relatively, you are dividing risk among this smoking. You want to use the risk among the smoking at the numerator, and the risk among the not smoking at the denominator. So the numerator, that is why you remember this 25 is A, B, C, D. So the risk here will be 25 people that develop lung cancer over the total that smoke. That's why 25 over 500. Everything divided by, because that formed the numerator now. The denominator will be 5 that develop lung cancer among the people that are not smoking over the total that did not smoke. 5 over 1,000. If you do it, it's the same thing as saying A over A plus B mean this is A, this is B. 500 is A plus B. This is C and D. C plus D mean this 1,000. So the formula is not so compulsory. It's better you appreciate when you look at the real value. Makes sense. So if you divide it, at the end of the day, if you solve the mathematics, it gives you 10. It's telling you that, and you see, the value when you divide 25 over 500 is 10 times more than when you divide 5 over 1,000. So the people that smoke, they are 10 times more likely to develop lung cancer than the people that do not smoke. So that's all. Very simple. So I think you have appreciated the formula now. So the odds ratio, now you can calculate it, but leave that one. Will be another. Let's look for the example for the odds ratio. These are the other slide when we use it for workshop. We run it also with expression. So the second one that explains the way the case control on. This one we just, the relative risk now is example for cohort study or experimental study. But this one is example for case control or cross-sectional study. Of 200 patients treated in the hospital, 50 have lung cancer. Of these patients, 45 are smokers. Of the remaining 150 patients, 16 are smokers. What is the odds ratio? Now, look at it. The total that develop, all of them, 200 people, 50 have lung cancer, 150 do not have lung cancer. Out of the 50, the total that smoke 105, you know, so 195. So out of the 50 that develop lung cancer, 45 smoke, 5 does not smoke. Out of 150, if you look at it now, I'm starting from the disease, the hardcore. The other one we started from the exposure. So out of 150 that did not develop lung cancer, 16 smoke. You can see 50 that develop lung cancer, 45 out of 50 smoke. 150 that did not develop, 60 smoke. From what you know that 45 out of 50 is greater than 60 out of 100, because 60 out of 100 is not up to half of this 150. Whereas 45 out of 50 is even close to everything. So it's a clue that most of those people that develop lung cancer smoke. But to quantify it, there are two approaches to it. And the reason there are two approaches to it is that the odds ratio can be calculated for for case control and cross-sectional study. It can also be calculated for other things also. So you make it to, you give it that leverage of having to have. So let's just look at the simplest way. Though this one here is just a shortcut. The formula you are seeing is one like a shortcut. But to demystify the shortcut, what we want to look at is the odds among these people that develop lung cancer. What is the odds of smoking? You know, the odds is probably risk over 1 minus risk. So it's very simple. If you say, okay, what is the probability that the risk of smoking now? The risk of smoking will be 45 all over 50. The risk of not smoking will be 5 over 50. If you say, and the odd will be risk over 1 minus the risk and the risk of the event and the probability of event and the probability of not event, 1 minus that event is the probability that the event will not occur. So 1 minus 45 in this is 5, because the total, the 1 here is 50, because that is the total. So the risk of smoking is 45 over 50. The risk of not smoking, which is 1 minus the risk, is 5 over 50. So if you arrange it now, it will still come by 50 will cancel 50. It will remain 45 over 55. 45 over 5. And that 45, can you see? 5 is down. Can you see 45 here? 5 over 5. For this one also, the risk, if you want to calculate the odds of smoking here, among the people that didn't develop lung cancer, if you calculate the risk of smoking is 60 over 150. The risk of not smoking is 90 over 150. So if you put the 60 over 150 divided by 90 over 150, which is the odds, 150 will, because by the time we change the formula, 150 will cancel 150. It will be 60 over 90. That's why you see 60 over 90. Can you see? Sorry, it will be, yes, it will be 60. Yeah, it will be 60 over 90. But when you now divide it, because that one will form the numerator. Because you are going to divide the odds here for the smoking over the odds for not smoking. By the time you divide it, 60 will not, 90 will change up. That's why. So because of that, you are now find out, okay, just say cross it, just say 45 times 19, which is A times D divided by P 60 times 5, B times C. That's why they call it cross product. Well, it's the workshop we try to demonstrate, have time to split it like that, to be solving it. Then when it's a workshop, you have time, a lot of time to be writing, to be explaining it and demonstrating. So the odds ratio is 13.5. What is telling you is that people that smoke are 30.5 more times more likely to develop lung cancer. So that is just. Now, how do you interpret? Maybe before that, just to show you, there's one here. Look at what I just demonstrated here now. Look at the cross product. Calculating odds ratio, all that. So A times D over B times C. So when we do work, okay, I think maybe you can demonstrate it today, because this weekend we are looking at, we're going to be discussing this weekend the workshop, or this weekend stratified analysis and logistic regression. And stratified analysis is about odds ratio also and relative risk. And that's why maybe for those who are called, we try to demystify this odds ratio. That's the way the formula is cross product like that. Now, let's look at the interpretation of the result. Interpretation of the result. If the odds ratio, so though I didn't include the formula for the confidence interval, it's a little bit complex, so maybe I don't need to be explaining to you. But once you understand what confidence interval means, whatever you calculate in your study is a statistic, because it's an estimate of parameters. That is, its summary is from your sample. Whatever you calculate from your sample is a statistic. Either the odds ratio, relatively, you're going to calculate is statistic, because statistic is what you summarize, is the summary of your sample. But the real thing in the population, for the population, is parameter. You can only know the parameter if you study the whole population. If you don't study the whole population, it's statistic you have. So the intelligent people now fabricated this confidence interval. After you have calculated the statistic, you now calculate a range of value. No, it's a two value. One will be less than what you calculated, one will be greater than what you calculated. What it's telling you is that even though This is the odds ratio 10, relatively 10 I've got it. But in the population, I'm 95% confident that it is in between this and this. Okay, something like that. Let's see the output, what I was just talking. Okay, look at this one now. This is the odds ratio, relatively 10 we calculated. The 95% confidence interval is 3.85 to 25.97. So what it's telling you is that even though I've calculated 10 for my sample, in the population, it's 95% possible. That is, you are 95% confident that, because in as much that you didn't calculate the other, you cannot be sure that this 10 is the same thing in the population, because it's an estimate. So, but you are 95% sure that, confident that it will be between 3.85 to 25.9, something like that. You can just be between 4 and 26, the range of value, and 95%. So it can be anything in between. So that is confidence interval for you. So the same thing with the really odd ratio, we calculate 30.5. Your 95% confidence interval is 5.07 to 35.97. Now, interpretation. If the odds ratio or relative risk is close to 1, there's no association between exposure and development of the disease. So, if it is 1, you know, you are comparing risk between the exposed and not exposed. You are comparing the occurrence of the disease between the people that are exposed and you put one over the other. And it's 1. It means that what you put in numerator and denominator is the same, because it is when you divide two things of the same value, when they are the same, that it will be 1. 45 over 45 is 1. 50 over 50 is 1. 1 million over 1 million is 1. So whenever you get 1, it means that the risk is the same in both exposure and outcome. It means that that exposure has nothing to do with the disease, because the risk, both of them, the people that are exposed and people that are not exposed, they have the same level of it. Actually, there is not that thing that's causing it. Now, a odds ratio relatively greater than 1 indicates a positive association between the exposure and disease. What does it mean? That since it's the one that is exposed that you put as numerator, if it's now greater than 1, it means that that numerator is far bigger. It means that, okay, that exposure is causing the disease. But it can be greater than 1, it may not be significant when you look at the odds ratio. But for the fact that it's greater than 1, it means that maybe it's causing it or is contributing to it. A relative risk or odds ratio less than 1 means the exposure is associated with less disease. If it is the other way, it's now less than 1, you now have 0 point something. That shows that the risk is less among the people you think are exposed, you put as numerator. The people you put below, you say they are not even the one you don't expect them to have it, they are the one that have the disease more. That shows that even that exposure is preventing that disease if it is less than 1. Now, the odds ratio or relative risk is often reported as a single number followed by a confidence interval, which I have said. The range of confidence interval include, if the range of confidence interval include 1, then the result is not statistically significant. Now, look at this. Look at this, a line here, 1. If the risk, okay, this is what I just explained now. It's not even the confidence interval. What I just explained here, risk less than 1. Can you see? Risk with exposure, if it decrease, your odds ratio will be less than 1. That should is protective. If the risk with exposure increase, it will be greater than 1. If it is 1, that should have there's nothing. Both of them, the risk is the same. The confidence interval also in this one, interpreting confidence interval. You can see, you know, we have already said that it's a range of value. So this dot you see in the middle is the value you calculated, or maybe 10 you calculated. Then the other value, the lower and the upper. You know, the confidence interval, the lower value will be less than what you calculated, the upper value will be more than what you calculated. So if, let's say, can you see? This is 1. Odds ratio or relative is 1. We already know anything on this side. If the odds ratio or relative is less than 1, that shows that the exposure it prevents the disease is less among the exposure, and that's why the arrow is pointing down. Then if it's greater than 1 on this side, that shows that with the exposure, the disease increases. But from what, like for this one now, it's telling you that for this on the left side, is preventive. That is, the exposure protective because the value is less than 1. On the right side is causing it because it's greater than 1. But are they statistically significant? You see, only the extreme one, this one, that the confidence interval is not cross that one line is significant, and this one. These other two that cross the line are not significant because we already known that on the previous slide that when the odds ratio is 1 exactly, you cannot say the exposure is causing it. You cannot say the exposure is preventing it. The exposure has nothing to do with it. That's what it means. So if and you say that your confidence interval is a range of value within which you are 95% confident that the real population value will be in between. So 1 is 1, and you know that if it is 1, there's nothing. So if by the time you calculate your confidence interval in the range, it starts from a 0 point something and hence somewhere after 1. So 1 has been captured. But what is telling you that it can be anything along this place, including this 1 that is captured. So and you know that if 1 it is 1, it means that it has nothing to do with it. The exposure has nothing to do with the disease. It doesn't even prevent it. It doesn't even cause it. So if irrespective of the value of your odds ratio or relative risk, either is less than 1, greater than 1, once the confidence interval crosses 1, it is not significant. It includes 1. So how you know is that it will start from 0 point something and hence something after 1. That after 1 can be 1,000, it can be 50, it can be anything, but it can be 1 point something, but it ends somewhere after 1. Once it crosses the 1, it's not significant. But if it does not cross, like for this one, if the odds ratio or relative is less than 1, and the confidence interval also is 0 point something, because if it's less than 1, it will be 0 point something, and the confidence interval also is 0 point something to 0 point something, it has not reached 1. It means that it's significant, but that particular exposure is preventing the disease and it's significant. If it is on this side, something after 1 and then somewhere after 1, since it does not include 1, it means that the exposure is causing the disease and it's significant. So whether the odds ratio or confidence interval is 0 point something or is something any greater than 1, once the confidence interval starts from 0 point something and then after 1, forget, it's not significant. So in that case, you don't even need p-value to interpret. You can use it to interpret. But of course, the result of the p-value will correspond. Because if it's not going to be significant here, so the p-value will not be significant. But the issue there is that the p-value, this one give more information than the p-value. I think there's still other thing to say about. Maybe it's taking long. Maybe we just stop here. We schedule it for another, maybe Tuesday. We'll continue because there's still some other things. Maybe too much. Let's just stop here. There's still some other truth to know about the relationship between odds ratio and relative risk. But I think it will be too much because if I start explaining it now. So let's just take question. Question? Question? No question? No chatted question? No chat.